So, yesterday we finished up with, I want to say, example 6.
Yeah.
That we finished up with. Okay. And yesterday, in my classes, I told you this already, but it didn't happen in all the classes. So, we said yesterday that if we wanted to find a distance, okay, so if we're talking the distance that an object is from the start, that means we're just going to straight up use the function. Okay? So the function is going to give us a distance. Okay? And then the other thing that we can do is an average rate of change over a certain amount of time. And so we said, this was way back on Tuesday, we said that the ARoC for a certain length of time, and I think we called it A to B, was equal to f of b minus f of a all over b minus a. The difference quotient is what we call that. And we said that that's how we find the average rate of change. Okay? And use that a lot. You'll use that a lot when you get older and you're like, oh, it takes me, how fast did it took me 22 hours to travel 1,600 miles. My average was, this, all that fun stuff. Because, you guys are going to be nerds like me when you grow up. Okay? Okay? And then we started it on Tuesday. And on Tuesday we said that the IRoC from some number, I'll just call it number, to, I think we said t, yeah. We said that was the limit as t approached that number. And we said then that this was f of t minus f of that number all divided by t minus that number. And so we said we had that, and we used that because we only did one per problem kind of a deal. Okay? But then yesterday, we said that the IRoC function that was equal to the limit as h approached 0. So we went on the interval, now we went on the interval t to t plus h. That was going to be f of t plus h minus f of t, all divided by t plus h minus t is what it should be. You know what I mean? It looks like this, but we just flat out said yesterday that that's always going to just be h. Okay. And then that allows us, we can do that one time, and then we can find the IRoC, the instantaneous rate of change, our velocity at any time. Okay? All right? So the function gives us distance. The ARoC gives us our average velocity. The IRoC tells us how fast we're going at that particular time. Okay? All right, let's do it. Let's get a little more complicated type of a function in here today. Today we've got t cubed minus 3t squared. Okay? So it says that in part A, excuse me, I'm just all excited because I got Panda Express for lunch today. Ooh, yeah, I did a little Panda Express last night. Wifey and I were out shopping for the party this weekend, so that was Lucas's grad party. Sunday. I don't even know what time it is. It's on Sunday sometime. Okay. Distance from the starting position after 6 seconds. So that would be f of 6 we were looking for here, because that's the function. So that's going to be 6 cubed minus 3 times 6 squared. Six cubed is not that big actually.
12 times 6.
No, it's not 12 times 6.
36.
It's 36 times 6, which is 216.
I just put it in my calculator.
Glad you guys have calculators out. Minus 3 times 6 squared. 6 squared is 36. Times 3 is 108.
Just get there.
So this object is 108 meters from the start after 6 seconds. Okay. Find me the ARoC for the interval 3 to 5 seconds. So that's 125 minus 75 minus 0 all over 2. So that's 50 divided by 2, which is 25 meters per second. Yes? Agreed? Okay. Now let's find the IRoC at any given time t. So that's going to be that way that we learned yesterday. So this is going to be the limit as h approaches 0 of f of t plus h. So that's going to be t plus h quantity cubed minus 3 times t plus h quantity squared minus f of t, which was t cubed minus 3 t squared, all over h. Okay. Now, one little trick in the mathematical world that might help you is something called Pascal's triangle. Okay. Pascal's triangle starts with a 1. And then the next line is 1 and 1. And then the next line is 1, 2, and 1. And these two combine to give me that 2. So the next line would be 1, 3, 3, 1. Always ends on 1s. Okay? Right? And the next line would be 1, 4, 6, 4, 1. Right? And so on and so forth. Well, this is helpful because this line up here is, oops, why did it not give me the right color? This line up here is t plus h to the 0 power. Anything to the 0 power is 1. Okay? Which means that this next line here is t plus h to the first power. If I fill in a t and an h. This next line is t plus h squared, t squared, th, h squared. First variable starts at the exponent of the power that you're taking and works its way down to 0. 2, 1, 0. Other variable starts at 0 and works up to the power that you're taking. 0, 1, 2. So then this would be t plus h quantity cubed. So it would start with t cubed h to the 0. T squared h. T h squared t to the 0 h cubed. Next one would be t plus h to the fourth power. T to the fourth power h to the 0. T cubed h. T squared h squared. T h cubed h to the fourth power. So this green one then becomes t cubed plus 3t squared h plus 3t h squared plus h cubed. Then we've got minus t cubed plus 3t squared. All of that is still over h, and we are still applying the limit as h is approaching 0. Now the nice thing is that this t cubed gets canceled out by that minus t cubed. Oops, I forgot. Tap the brakes. I forgot this whole part too. And then we've got a minus 3. Let me, hold the phone. Let me just reset. I got so excited to do some math that I totally forgot about the minus 3t squared. So then this is going to be minus 3t squared minus 6th minus 3h squared. Then oops, I didn't have to put that there. I went this way. Getting all jazzed up here about this math. There we go. Now that t squared cancels out that negative t cubed, and this negative 3t squared cancels out this positive 3t squared. That's what we needed. We need to get rid of those t terms. So now we've got the limit as h approaches 0 of 3t squared h plus 3th squared plus h cubed minus 6th minus 3h squared, and all of that is still over h. Do all of them in that numerator have an h term, or an h part, I should say, which means I can divide by h then, and so then my limit as h is approaching 0 would be 3t squared plus 3th plus h squared minus 6t minus 3h. Yes? And now I can send h to 0. So anything with an h goes away. If I send h to 0, then 3t squared is safe, but that term is gone. That term is gone, and that term is gone. Negative 6t is safe. So my IRoC function, oops, I put IRoC, not IRoC, at any time t is going to be 3t squared minus 6t. So now if I need to, which in the next one, in letter D, it says, what is the IRoC? What is the IRoC at a time of t equals 1, t equals 3, and t equals 5? So now, because I have my derivative, or my IRoC at any time t, is 3t squared minus 6t. Because I have that, now I can say here that at t equals 1, that's going to be 3 times 1 squared minus 6 times 1. 1 squared is 1, times 3 is 3, minus 6 times 1 is minus 6. So that gives me an IRoC of negative 3 meters per second for t equals 1. Agree with that? What does that mean? Means I'm moving backwards, right? Okay. I started and I'm on a track and I'm supposed to be going that way, but instead of going that way, I'm going backwards. I'm going away from the pole in the opposite direction. Okay. T equals 3 was the next one. Three squared is 9, times 3 is 27, 6 times 3 is 18, 27 minus 18 is 9 meters per second. At t equals 3. What does that mean? Moving which way? I'm moving forward. Okay, so if I was moving backwards at t equals 1, now at t equals 3 I'm moving forwards. What does that mean happened sometime in between t equals 1 and t equals 3? It stopped, right? Because I had to stop to change directions. I was moving backwards. I stopped ever so briefly. Now I'm moving forward. Okay. All right, and then we've got t equals 5. Five squared is 25, times 3 is 75. 6 times 5 is 30. So that we're moving at 45 meters per second at t equals 5. What does that tell me? It means we're accelerating. We're accelerating as we're going forward. Okay. All right, I love it. Next question says, when does the object stop? That's a good question. When does the object stop? But how can I figure out what exactly it is? Set what equal to 0? Set my IRoC equal to 0, right? So if I set my IRoC equal to 0, so my IRoC was 3t squared minus 6t. If I set that equal to 0 and solve that for t, that's going to tell me where I stopped. Yes? Using your math skills, figure out when our object is stopped. Stopped twice, right? So we're stopped at the start. Then we went backwards because we said we were moving at t equals 1. We're moving in a negative direction. So we went backwards. We stopped at 2. And then we started moving forward again, right? Okay? So then the last question says, where is the object when it stopped? Now, there's two ways of doing this. The first way is algebraically, and I will do that one with you right now. Okay? So the first way is algebraically. If we stopped at t equals 0, then I would need to find f of 0. And my function again was t cubed, so that would be 0 cubed minus 3 times 0 squared. 0 cubed is 0. 0 squared is 0 times 3. 0. 0 plus 0 is 0. So I am at 0 meters when it stops. So we are stopped at we're 0 meters away. That's one way of doing it. But then we also stopped at t equals 2. So I need to find f of 2, which is going to be 2 cubed minus 3 times 2 squared. 2 cubed is 8. 2 squared is times 3 is 12. 8 minus 12 is negative 4. So at t equals 2, we are at negative 4 meters away. Okay? That's the algebraic method. We found when it stopped by setting our IRoC equal to 0. Then we plug those values into our function to figure out where it stopped. Okay? The second method is graphically. Now, if I choose to graph my original function, f of t is t cubed minus 3t squared. If I choose to graph that, okay, I'm going to find that I've got zeros at, because if I factor this out, so if I go t cubed minus 3t squared equals 0, I factor out a t squared, leaves me with t minus 3. So then I would have t squared equals 0, t minus 3 equals 0. So I'd have t equals 0, and then I have t equals 3. So I'd have zeros at 0 and 3. Agree with me on that? Okay. It's cubic, so it's going to go in opposite directions. Because it's a positive a value, oops, here, let me scroll up just a little bit here. Because it is a positive a value, it's going to come up from below. It's going to come up from below, and it's going to kiss at 0. Because at 0 is a double. So that's a kiss. It's not a shoot through, it's a kiss. Then it's going to turn around, and algebraically, we found that it was at 2, negative 4. So then it's going to come back down here, and then it's got to come back up here and cross, and then it's going to go shooting up. With me on that? Graphically, we know when an object stops because it changes direction. So here would be a stopping point because we were coming towards the starting line or the starting position, and then we stopped. We went away from the starting position. Then we stopped here. This would be another stop, another change of direction. Okay? We call those critical points. Okay? Those are changes in direction of the graph. Okay? So those are the 2 stoppage points. This first one would be that one, and this one would be that one. That's how we can find those. Okay? I don't know, you tell me. What does it say?
It says fin.
It says fin. You know what fin stands for?
Fin.
And in French. Okay. You have 3 worksheets now. You have worksheet A, you have worksheet B, and you have worksheet C that you picked up today. If you noticed over here on the cabinets as you come in, the answer keys are posted here. We are not posting them online, we're only posting them here in the room, okay?